In this video, we'll explore mathematical functions. Now, some helpful terms that we have are that a relation is going to be a set of ordered pairs, which also could be an equation. Y equals 2x plus 5 is a relation in which all the ordered pairs that satisfy that specific equation. A domain is the x coordinates within the relation. The range is going to be the y coordinates within our relation. And then a very special type of relation is a function, in which every x value corresponds to exactly one y value. So here's an example. Here's my relation. In this case, it is literally just a set of 4 ordered pairs. If I wanted to know the domain, I would just look at what are my x values. So in this case, I would have 0, 3, 9, and -1, but I put them in numerical order, and I put that brace around them to say that these are the elements that are in the domain. When I look at my range, I'm looking just at my y values. So I have these 4 y values, and again, I put them in order numerically and put the brace around them. If something showed up more than once, I would only write it one time. Now I'm going to look and say, well, if I want to say, is this a function, I'd be looking at the ordered pairs and looking at my x's, -1, 0, 3, and 9. Each of them only has one y value it corresponds to, so this would be a function. So how do I tell if an equation is a function? What I want to do is I want to rewrite it for y, and I want to look and say for every y, does it create more than one possible solution when I have the specific x plugged in? Or I could also graph it and say when I graph it, does it hit the line, does a vertical line hit the graph at more than one location? So let's look at both of these methods. Say I have y equals 1/3 x minus 5. Any x value I plug in is going to give me exactly one y value, because this is creating a line with a slope of 1/3 and a y-intercept of -5. So this would be a function, and I can graph it, and here's the graph. I can see if I put a vertical line and I run it across my graph, I'm always hitting the vertical line exactly one time, and that's the point. Now say I have y squared plus x equals 9. Well, I need to rewrite this for y equals. So I move the 9 over, and now I take the square root of both sides. Now the thing to remember though is when I take the square root, my solution is plus or minus that square root. So that means if I plug in a value for x, say 0, 9 minus 0 is 9, the square root of 9 is 3, but that means for an x value of 0, I want to have plus or minus 3, two different possible solutions for my y value. That tells me this is not a function. So if I graphed it, I would see that I have a sideways parabola, and when I run a vertical line, I can tell that I'm hitting my line twice, just about everywhere I go except for right at the vertex. Now if I need to find the domain of a function, I'm going to start by assuming that it's the real numbers, and you can use the braces and this fancy R. Typically, sometimes you'll see a double bar for the vertical line and then draw your R. And then we want to look at special cases that may need us to remove aspects from the domain. For example, if I have a denominator with an x in the denominator, I want to set my denominator equal to 0 and determine what values would make that denominator become 0. They can't be part of the domain because they make the function disappear. Also, if I have radicals with an even index, so 2, 4, 6, 8, etc., I want to take that interior and set it to be greater than or equal to 0 because I can't have a negative inside the radical of an even index. So let's look here. I got f of x equals 2x plus 1. Well, I can plug in any x value and that will give me a corresponding y value. So this domain is all real numbers. There's no special thing happening here. If I look at my next example, x over x squared minus 9. Well, in this function, I have this denominator of the x squared minus 9. That means there's going to be some value I could plug in for x that could make this disappear and become 0. So I'm going to set that denominator equal to 0, and I'm going to solve. I'm going to move the 9 over, take the square root of both sides, and remember, when I take the square root, that gives me plus or minus 3. So that means every number will work except positive 3 and negative 3. And the way I write that is I'm going to put brace, I put x. This vertical bar means such that x does not equal 3, comma, because there's another thing that I need to relate, x does not equal positive 3, and then close my brace. This is just the way I'm going to write these special cases when I'm trying to exclude something. So if there was something else, I'd put a comma and then list the next thing that it would be limited with. Now say I had f of x equals the fourth root of x minus 5. Well, here I have an even index, so I know my interior has to be greater than or equal to 0. So I set my interior greater than or equal to 0. I add 5, so x has to be greater than 5 or equal to. So the way I write that is just put it in the same format. My domain, got my bracket, x such that x is greater than or equal to 5. Close bracket. If it had a denominator and something else, I'd put a comma, x cannot equal blank. So I can put all those aspects here and I just list each thing with a comma in between each of the different aspects. Now if I need to find the value of a function, I'm going to end up just directly plugging it in for x, and that's because my x value is the independent variable in a function, whereas f of x represents the dependent. It depends on what my x value is as to what my y value becomes. And we use that term for that very reason of the dependence of the y value in this case. So let's look at some examples. Say I have the function of x equals 3x plus 7, and I'm going to find and evaluate at different aspects here. So f of 4 means I'm literally going to plug a 4 in for x and simplify. 12 plus 7 gives me 19, so the function at 4 is 19. If I had x plus 1, that means I'm going to replace my x value with x plus 1. Now I distribute the 3 to both terms so that I get 3x plus 3 plus 7. So 3x plus 10 is going to be equal to the function of x plus 1. Now this third one's a little bit different because it's saying I'm going to want to do 2 times the function. Well, the function is 3x plus 7, so I'm going to do 2 times the 3x plus 7. And that's where the unique aspect of this is. So sometimes if it's inside, I'm replacing the x itself, whereas if I have something outside, think about that I have to multiply it by the entire function. I distribute the 2, that gives me 6x plus 14. It's going to be equal to 2 times the function of x. If you think about it, 3x plus 7 and 3x plus 7 would give me 6x plus 14. Now we can do other operations of 2 different functions as well, and you just have to pay attention to the way they're written. If we have the 2 terms together in parentheses f plus g, that quantity of x, that means I'm adding the 2 functions. With subtraction, I'm subtracting the 2 functions. Multiplying means I'm multiplying the 2 functions, and dividing means I divide the 2 functions as long as the bottom one does not, or the denominator does not create 0. So say here are my 2 functions, 2x cubed plus 3x, and then g of x equals 5x. If I wanted to do f of x plus g of x, I literally would just add those 2 functions together. Well, what can I combine? I can combine the 3x and the 5x to give me 8x. So f plus g of x is 2x cubed plus 8x. Now say I want to look at multiplication. I would literally multiply these 2 functions. Now just pay attention to the fact that I have a single term and I need to distribute it to both terms in the other expression. So I'm going to distribute the 5x to both terms, and that's going to give me 10x to the 4th and 15x squared. So f times g of x is going to give me 10x to the 4th plus 15x squared. Now say I want to do the function of f divided by g of x. I'm going to divide 2x cubed plus 3x by 5x. Now when I get this type of expression, I need to make sure I pay attention to how do I simplify. In essence, when I have a single term in the denominator and two terms up top in the numerator, I'm looking saying what can I simplify and divide all three terms by. In this case, I can remove a x from all three terms so that my simplified division would be 2x cubed plus 2x squared plus 3 over 5.